So in 7.2, we're going to talk about degrees and radians, how they're related, what they are. Most of you are familiar with degrees. We're going to talk about converting back and forth between degrees and radians. We're going to talk about what a radian is. There is a button on our calculator if we're using radian measure. It's going to be different than if we're using degree measure. And then we're going to have some real world problems. We've already done some in 7.1, but just kind of a further application of that stuff. So some things to remember about angle measures. Degree is the most common form of measurement of angles. It's the one that you are introduced to when you're first introduced to how to measure an angle. Remember some numbers from back in the day. 180 degrees is the total inside a triangle. We've seen that happen in our right triangle trig from section 7.1. 180 degrees is also a straight angle. So you might recall back in geometry class, a straight angle would be if we measured from there to there. So a straight line. And it would make sense that a straight angle would have a 90 plus a 90 is 180 degrees. So the word supplementary means that two angles add up to 180, or a straight angle adds up to 180, or a triangle, three measures inside of a triangle always add up to 180. So 180 appears a lot in the things we do. 90 degrees is the word complementary. So those words could be used here and there for our trig stuff. Remember, you can also call that a right angle. And here's the fact that's a little new and a little different. A degree has 60 minutes in it. Now, that is not a time minute. That is an angular minute, okay? Now, you might see on a GPS something that looks like this. So I'm just going to give you an example. Let's say that we are at 5 degrees, 60 minutes, or 6 minutes, and 17 seconds. What does that mean? Okay, so this would be your degrees, this would be your minutes, and this would be your seconds. If you took a degree wedge, so a degree is very small. If we broke that down into 60 pieces, that's the size of a minute. If we took that and broke it down 60 more times, that would be the size of a second. So it's used because the Earth is so huge. If we just said we are on the 5 degree line, wouldn't tell you a whole heck of a lot. So this breaks it down. This is a 60th. This is a 60/60th, or a 3600th of a degree. So it's a very super teeny tiny wedge. Okay, so all this notation means this is degrees like normal.
So wait, it says 5 degrees, but that says that 1 degree is equal to 60 minutes. So wouldn't that just be an hour in 6 minutes and 17 seconds?
It's not time. So it's degrees, 5 degrees, 6 minutes, and 17 seconds. It's a way for us to break down a degree. So we would have 5 degrees. We would have 6 out of 60 more, and then we've had 17 out of 3,600. It is a way for us to break it down into smaller pieces. So it is used for GPSs. If you looked at our exact location on the Earth, you would see it would use degrees, minutes, and seconds for latitude or longitude. So this is used if you need to break down a degree measure even further. So this just means it takes 60 minutes to make a degree. It takes 60 seconds to make a minute. So you could also add that this is 3,600 seconds. Okay, so it is just a way for us to break down degrees even further. And it is used a lot for navigation, whether it's a plane navigation or boat navigation or GPSs. They all will use that sort of notation. So it's just something you might not have seen before. There you go. So let's look at an example. If we have 329.125 degrees. And we want to put it in degrees, minutes, seconds form. That's what this means. Degrees, minutes, seconds. That's what that means. This is what you're going to do. We know for sure that the whole degrees we have are 329. So we're going to take off the decimal and we're going to multiply it by 60. How many 60ths are there? Now, if you multiply it by 60, 0.125 times 60 is 7.5, okay? This number, because I multiplied by 60 and there are 60 minutes in a degree, that is how many full minutes I have. I have 7 minutes. Now again, that is an angular measure, that is not time. They just call it that, okay? And now we're going to take off this decimal and we're going to multiply it by 60 again. So we've multiplied it by 60 twice. The first time is going to give us the minutes. The next time is going to give us the seconds. And so that would be 30. So again, let me go over what I did. The full degrees is just how many degrees you got. Take that off. In your calculator, you're going to put in the decimal value times 60. 0.125 times 60. You're going to take that off. That's our minutes. Then you're going to take the decimal again, multiply by 60 again, and that is your seconds. Okay? So we keep using that 60 because of the fact that there are 60 of those that make 60 minutes make a degree, and then we do it by 60 again because 60 seconds make a minute. Okay. Now in part B, we're going to go the opposite direction. So let's think about what we know. This notation, this is our degrees, this is our minutes, this is our seconds. So let's talk about how to put it back into decimal form. It's 35 point something. So we know for sure that it's 35 point something, but we just got to figure out what's the something, okay? And here's how you do that. In your calculator, you're going to put 35. You're going to divide the 12 by 60 because of the fact that there are 60 minutes that will make a degree. And I only got 12. I have 12 out of 60. For the seconds, we have to divide that by 60 twice. 60 and times 60 is 3,600. So I always just put 3,600. So just throw that into a calculator. 35 plus 12 divided by 60 plus 7 divided by 3,600. And if you take it to the nearest thousandth, like they have expressed that they want you to do, that would be 3 decimal places. That's 35.202 degrees. Please put the degree measure on there. Put the little degree mark if you're using degrees. Put the minutes or seconds if they're minutes or seconds. Please use the notation that's given, because if there's nothing given, we associated that with radians. So if it's a degree, I need to know it's a degree. Put a degree symbol on there. Okay, so that is how we go back and forth between degrees and degrees, minutes, seconds. So that's an example. And it's all based on that 60 idea. 60 degrees, 60 minutes make a degree. And then 60 of those tiny seconds will make a minute. So that means 3,600 of those makes a degree. Okay. So you just have to know that. You just have to know those facts of how those things are related. Okay. So that is degrees, minutes, seconds. Now let's talk about what a radian measure is. So if we have some central angle, now this goes back to geometry, and you know how before I talked about alternate interior angles, some of the terminology from geometry is going to rear its head. We're going to find that terminology. So right here, a central angle is an angle with the vertex at the center of a circle. So here's the center of our circle, and so if our angle goes out from that center with a vertex at the center, that is considered a central angle. And we're going to put that theta right there. Now, radians are the measure of the central angle, where theta is S over R. Now, look where the S is and look where the R is. The S is your arc length. The R is the radius of the circle that you're in. So your radian measure is actually a comparison of how far did you sweep across the circle, that S, and how big was your circle, that R. So it's S over R. So R is the radius of the circle, and S is the length of the intercepted arc. So again, you're going to hear some terminology from your geometry class back in the day. Some facts to know. The main one is this one, that pi radians is 180 degrees. Because a radian is related to an arc length, the distance around our circle is 2 pi r. Remember the circumference formula, 2 pi r? Pi is going to show up. Halfway around the circle is a pi worth of radians, 180 degrees. That is from here to here. The full flip around the circle we know is 360 degrees, but in that case, as far as radians go, it'll be the intercepted arc, 2 pi r divided by r, which just gives us 2 pi radians. So the fact you want to know is this one right here. You have to have that memorized, and I'm going to dig it into your brain that a pi worth of radians is 180 degrees. Now, if you take 180 degrees and you divide it by pi, 3.14, you'll find that 1 radian is about 57.3 degrees. So a radian, if I say I have 1 radian, you have to equate that in your brain with something that's super close to 60. So 1 radian is about that much. That's about 1 radian, a little more than what's in the picture. So I would say a radian is about that much, a little more than 45. Okay, so a radian, okay, so a radian is about 57.3 degrees. But know this fact right here. That's the fact you want to have memorized, and then you'll be good to go. So there's going to be a conversion we need to know. Because 1 pi worth of radians is 180 degrees, if we want to convert degrees to radians, we multiply by pi and divide off 180. So if we have the degrees, we're going to tack on a pi and divide by 180. And the standard is to leave it in fractional form. So you're going to see radians say pi over 2, pi over 6, 3 pi over 7, stuff like that. But for 2 to go the opposite way, if we have the radians, we're going to multiply by 180 and we're going to divide off the pi. Now, if there's an actual pi sitting there, we'll just get to cross that out. If there isn't a pi sitting there, you're physically going to want to use 3.14. So most of the time for radians, so this is radians, and this is degrees. For radians, the pi stays in the problem most of the time. For degrees, we need to divide off the pi. We need to divide by 3.14. You're not going to see the pi. So radians, you usually see a pi in the problem. Degrees, you usually don't. That's customary. So I'll show you that when we get to problems like that, where, again, radians, you'll probably see the pi and it will look like a fraction. Degrees, it won't. You want a number, because we know that, 48 degrees looks about like this, and we can use a protractor. Okay, radians, we can't quite do that, but we'll get a sense of what radians are the more we use them. So let's practice converting back and forth. It says I have 135 degrees, and we want to write that in radians as a multiple of pi. Now, customarily, I want the pi showing, and that's what they want to most of the time. So what do? Well, if we know the degrees, remember, we tack on a pi, put it over 180, and then we're going to reduce. So let's do that. So we're going to write down the degrees. No degree symbol anymore because now we're going to make it into radians. We're going to tack on a pi, put it over 180. Now, both 135 and 180 are divisible by 9 and also divisible by 5. So technically divisible by 45. So no matter how you end up reducing it, if you reduce it, you could first divide by 5 if you wanted, which is 27 pi over 36, I believe, and then divide by 9. But no matter how you slice it, you need to get it reduced down as much as possible, and that's your answer. You're going to leave the pi in the problem. That's what they mean by write it as a multiple of pi. Now, for the first time, we're going to have degrees that may have a negative with it. Now, that's going to be a directional thing, and I will explain what that negative means. For now, just leave a negative on there. Let's do it again. So we're going to write down our degrees, tack on a pi, put it a 1 over 180. And, that's going to give us our radians. Now, if you'll see that they both end in a 0, then they're divisible by 10. So we could divide by 10 really fast. And then check again, can we reduce it any more? Well, 3 does go into 18, or just as 30 goes into 180 6 times, that's negative pi over 6. And that's radians. Now, the abbreviation for radians, they'll put rad next to it. I don't need that. If I see a pi there, I'm going to expect that it's radians. But if you want to put the RAD, you're welcome to. There's no real symbol like there's a degree symbol. The pi kind of gives it away that it's in radian mode. So that's how we take a degree and turn it into a radian. Not a bad process. Tack on a pi, put it over 180, reduce. To take a degree and make it a radian, tack on a pi, put it over 180, reduce. That's what you do every time, okay? And it doesn't matter whether it's positive or negative. I'll discuss what the negative means eventually. But for now, tack on a pi, put it over 180, and reduce. Any questions about example 2A or B? Okay. So now let's go the opposite way. Think about what happened. We tacked on a pi, that was in the top of our fraction, and we put a 180 on the bottom. So here, if we have the radians, we're going to multiply by the opposite fraction. We need to multiply by 180 and divide off the pi. So it's just the opposite, the reciprocal of what we started with. So 2 pi over 3, multiply by 180, take off the pi. So if there's a pi in the problem, take it off. I don't need the pi anymore. Yes? I'll show you in a minute. So next, you're multiplying these fractions. So it's really 2 times 180 and then 3 times 1. So you end up dividing by the 3 and multiplying by the 2. So it's 2 times 180 divided by 3. That's the math you end up doing. 2 times 180 divided by 3. Well, yeah, you're always going to multiply by 80 and take off the pi. Multiply by 180, take off the pi. 3 goes into 360 120 times. These are degrees now. Put that degree symbol. I need to see the degree symbol. I don't need to see anything for radians because I'm going to assume I see that pi there. It's going to be a radian. Let's do it again. Multiply by 180, take off the pi. Now, you don't have to write the pi. You can just take it off, but I like to actually physically take it off. Multiply by 180, take off the pi. Well, 3 times 180 is 540, so that's negative 540 divided by 4, which is 135 degrees. You have to know this. We are going to keep building facts on and on. So far, what facts do we know? SOHCAHTOA, the reciprocals, cosecant, secant, and cotangent, Pythagorean theorem, degrees of an angle add up to 180. To take degrees and make it radians, tack on a pi, put it over 180. To take a radian and make it degrees, multiply by 180 and take off the pi. We're going to keep building these facts because they're all going to start going together. So it's really important that you memorize and know these facts. Okay? Any questions about example 2, C, or D? Now, we need to talk about that placement of an angle. We need to talk about when we have a angle that is sitting inside of a circle or is sitting at the origin or of our XY plane. The side that doesn't move, I think of as my initial side, my starting place. And then you want to think about this terminal side has rotated up to some angle measure. Now, we're used to theta, but I wanted you to see another angle measure that's used often. That's an alpha symbol. Think about a little fish when you were making fish as a kid. Just go down, loop around. That's an alpha symbol. It's like a little fish. Down and around. That's an alpha symbol. So Greek letters are going to be used a lot. Remember, the one that you start at is your initial side. We're going to use our initial side going in the positive x direction most of the time. And then our terminal side is our side that rotates up. So it might rotate and stop here. So that's our alpha. It might rotate and stop here. That's our alpha. It might rotate and stop way down here. That's our alpha. So that side, just think of the one initial side is stuck. The terminal side is spinning, and it's going to, the direction we spin that side is going to depend on whether it's positive or negative. Remember, a full rotation is 2 pi radians or 360 degrees. There's some terminology I need you to know. We're going to talk about coterminal angles. They end up at the same terminal spot. So we might rotate around to get to a terminal spot. This is an alpha, by the way. It says that alpha is coterminal with any angle where we either add on 360 k, where k is some integer multiple of 360, or we add on 2 pi k if we are dealing with radians. Okay, so coterminal angles end up in the same spot, and we can find lots of things, because think about if I'm here, there's my angle. But think about if my terminal side, actually think about like a spinner for a pinwheel. It spun, and it landed there anyway, one time around. Or maybe I spun it this way and it landed there the backwards way. So a coterminal angle lands us in the same spot. So there's just some terminology, okay? So we're going to be placing the vertex of our angles many times at the origin. Here is your initial side. That initial side, 99% of the time, is going to be on the x-axis. The terminal side is going to rotate. So it's the spinner on our spinner. It's the spinner on our pinwheel. Now, say that we land here. Well, how did we get there? Well, maybe I just went bonk right there. That's a possibility. Couldn't I have spun this way, gone there and got there backwards? Couldn't I have spun 5 times and got there? All of those times where we land in that same spot will always be coterminal with what we started with. So if I land in the same spot, it's coterminal. And we're going to discuss that more and more. But let's, for example, let's say I've measured this, and let's say that this is 40 degrees. I don't know what it is. I don't care. Let's say it's 40 degrees. And that I got there, and that's my alpha. That is not an alpha. Let's say that instead of going up, let's say that I rotated this way and stopped. That's called beta. Alpha and beta landed in the same spot, so they are considered coterminal. They are considered coterminal. So you've got to think about the fact that this is rigid. The initial side is stuck on that x-axis. The vertex is here at the origin. This is our pinwheel, and I can either rotate it up to get to 40 degrees, or I can rotate it backwards to get to 40 degrees. Technically, that is 40 minus 360. That would be negative 320 degrees. So negative 320 and 40 are the same. They land us in the same spot. If you put into the calculator the sine of 40 and the sine of negative 320, it's going to give you the exact same thing because of the fact that we have landed in the same spot. Okay, so we got to get used to the fact that language, that coterminal, means I have landed, as I rotate around the x and y axis, I have landed in the same spot. And since one full rotation is 360 degrees or 2 pi radians, I can land there by adding 360 or subtracting 360 or adding 2 pi or subtracting 2 pi. Okay. So it's kind of just a new way of thinking about what an angle measure can be. So we finally have some like positive and negative sorts of things. So that's when it comes to positive and negative directions. If the terminal side rotates counterclockwise, so if that terminal side goes counterclockwise, so I'm talking that way, my rotation is positive. If my terminal side rotates clockwise, downward, the direction it's going is negative. So here, if my terminal side, if my initial side is where it should be, right here, if my terminal side rotates up, that would be positive. If it rotates down, that would be negative. So like this one looks like it's about, that's like a positive 40 degrees. And this one looks like it's maybe 45. It's almost exactly 45. I think negative 45 degrees. So that's the difference. It is directional. So for the very first time, a negative means something. It means the direction that we are going. And so it's not going to be in the triangle. We can't be in a triangle per se. We are going to use something called a reference triangle, but it's now outside the triangle. Our angle is rotating around the x and y axis. So let's practice drawing these. It says identify all angles that are coterminal with 80, then find and draw one positive and one negative angle coterminal with 80. Okay, so do you see the words here, all angles? What we're going to do is we're going to write 80, because it's degrees, we're going to add 360k, where k is an integer. Now let's review this notation. This means k is an element of that little e, that little rounded off e, of z's, which are integers. So that notation just gets written after every time, okay? So that is all angles. If I add some multiple integer of 360 to 80, I got it. Now, they said to find one positive and one negative, okay? So for one positive, we're just going to add one 360. We could add two 360s if we wanted, 720, we could have. But 80 plus 360 is 440. To find a negative, we're just going to subtract 360. which is negative 280 degrees. Now, they ask us to draw them. So let's pick about where 80 is, just guesstimate, okay? Think about the fact that's 0, that's 90, that's 45. Just make a guesstimate where 80 is. If you want a protractor, you go for it. I don't care. So the first thing we're going to do is we're going to draw our original angle. We're going to make a little arrow that says this is 80 degrees. Okay, so that's our original 80 degrees. It's about there. It's about 10 degrees before 90. I could have made it even closer to 90, but guesstimate. Okay, so that's our original. Now let's draw 440. Now, how do we draw 440? Well, one rotation around is 360 plus 80 more. That's exactly what we did. 80 plus 360 gets me to 440. So how do I draw that? Well, you're going to make a rotation around to 360 and get to 80, and that is 440. Okay, do you see how we did that? 360 plus 80 is 440, and I went in the counterclockwise direction because that's the positive direction. Now let's do negative 280 by going in the negative direction. We did 80 minus 360 to get negative 280. So we're going to go backwards. That's where negative 280 is. So we're going to start over here. We're going to go in the negative direction. That is negative 280. So you're going to use those little swirls to tell me how you got there. Okay. So draw your original in one color. Draw your positive, which goes in a counterclockwise direction once around and hits it. And then start at 0 and go backwards and hit it. And that's your negative one. Okay, that's always how you're going to draw. You're going to draw one positive, one negative, and the original. Okay? Okay. Everybody kind of see how we got what we got, how we got it. Good? Okay. Let's do it again. Now, this time is radians. Excuse me. For radians, my suggestion is, anybody in this room right now besides me know what pi over 4 is off the top of their head, how many degrees that is? Probably not. No. Pi over 4 is 180 divided by 4. Which is negative 45 degrees. A pi worth of radians is always 180 degrees. You have to know that pi is 180. Pi is 180. Pi is 180.
No, why is it 180 not what it normally is?
Well, it is 3.14 radians, but to convert that to degrees, we multiply by 180 and divide off the 3.14, and so then that's the conversion. You just have to know that a pi worth of radians is 180 degrees. You have to know that fact. Okay, so here's my suggestion. Until you know radians really, 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 really well, turn it into degrees. Let's do the math for degrees. If we were going to keep it radians, the all angles, this right here, means that we add or subtract 2 pi k, where k is an element of the integers. That is radians. I don't care if you do that. That's fine. But you can do what we did for the last one by just adding 360k to the negative 45. I like degrees. I can see degrees better. I can work with degrees better. Eventually, you'll start to know, and eventually you'll know pi over 4 is 180 degrees. You'll just know that fact. But until that time, take off the pi, put on 180, find the degree measure, because you know how to draw a degree. Okay, so let's draw our original. Our original is negative 45, so it's going to go down here. So remember, negative means that I rotate downward. I rotate clockwise. So draw your original. Yes, that's negative pi over 4. I don't care. Pick if you want degrees, use degrees for now. Okay. Now let's do a positive and a negative. Negative 45 plus 360 is 315 degrees. Now let's draw. How do you get to 315 degrees? Well, we're going to start at 0. We're going to rotate counterclockwise until we hit it. Okay. Now we already had a negative, but they want another negative. So just subtract 360 this time. That's negative 405 degrees. Now, how do we do that one? Let me pick a different color because that one doesn't look much different. We're going to start at 0. We're going to go in the negative. We're going to go in the negative degree. We're going to go 360 in that, and then we're going to have to land there. So we have to go down 45 more. I've gone a total of 405 in the negative direction. Let me show you again. I started at 0. I went down 360, 45 more. Because I have to land at the spot that was given. So that is negative 405. So to find a positive, add 360 till it gets positive. To find a negative, subtract 360 until you get a new negative. So that's how we do radians or degrees. Feel free to use the radians, but I'm telling you for now, make them degrees before you do anything else. Everybody okay with that fun stuff? We good? Okay. One more example. So it says identify one positive and one negative angle that's coterminal with 126. Do you see how they did not say the words all angles? So we don't have to do that plus 360K. If they don't say the word all angles, we just need a positive and a negative. So we're just going to take 126 plus 360 and 126 minus 360. 126 plus 360 is 486. 126 minus 360 is negative 234. Okay. Now let's do a little bit of let's write on our XY axis here. This is 0. If I rotate up, this is positive 90, 180, 270, 360. Okay. That's one full rotation. So if I start here, 90, 180, 270, 360. Okay. Let's draw our original 126. Well, if this is 90, 126, 120 is about here. So 126 is about there. Just do a guesstimate. I don't care. Do a guesstimate. And then mark that. Hey, that's where I think 126 lands me. Just do an approximate. Okay? Okay. Now, how do we do 486? 486. What did we do to get 486? We added on 360. We added positive direction. So we're going to go one flip around, 360 plus 126 more. That's 486. Coterminal lands me in the same spot. This one, I subtracted 360. So I'm going now in the negative direction to get there. So now start at 0. Go in the negative direction to get there. That's negative 234. And that's it. Okay. So for the homework here, you are doing some conversion of degrees and minutes, and you're doing some radians to degrees and degrees to radians. You're doing coterminal. Please, for this section, draw me the swirls. And then you can try those things right there. So there's your homework. Okay, so there you go. Do your thing.
Can you scroll back up?
Mm-hmm.